Hello everyone, I am Vaibhavi Chopde pursuing Civil Engineering BTech and I am now in second year. My institute name is MIT Academy of Engineering Pune. Today I am going to explain the topic of geotechnical engineering and the topic is soil structure and its classification. Let's begin. Soil structure. The soil structure is the arrangement of the solid particles of the soil and the pore spaces located between them. It describes how the soil particles and the pore spaces bind together. Soil structure is not a stable parameter. It varies depending on the weather conditions, management, soil processes, etc. For example, in a particular place, if the weather condition today is a rainy day and tomorrow it is a summer day, like this, due to this the weather condition has changed, so there are changes in the soil structure also in the soil. So therefore weather condition is a major factor which affects the soil structure. And for example, if the earthquake happens or any kind of natural calamity happen, there is a change in the soil structure of a soil. So the important causes are, the first one is expansion of swelling clays during wet periods. Second is rain, especially if it results in a violent dilution of cations, which promotes flocculation of the colloids. Loss of organic matter in cropped or eroded soil. It also affected by ac- acidification, resulting in destabilization of microaggregates. The classification of soil structure. Soil structure can be classified according to the presence of colloidal soil particle and their interaction between the coastal particle. It is classified in the three categories, and the first one is the single grain. In single grain, the colloids are scarce and soil textural composition is dominated by coarse particle. In the single grain, the soil particles are loosely binded. The second one is aggregated. In aggregated, the presence of colloids is moderate and coarse particles are arranged in small clots or aggregates. So the third one is the massive. If the in this the presence of colloidal particles is dominant and soil appears cemented in one great mass due to the decrease of the pore volume. These are the examples of single grained soil. This one we can see that this is desert area. In desert area, the soil particles are so loosely bounded that we know that. And this we can see that the soil particles are loosely bounded. They are not strongly binded. There are more spaces between them. And this is also the example of single grain soil. In aggregated soil, the soil aggregates are group of soil particles that binds to each other more strongly. There is a strong bond between them in the adjacent particles. Soil aggregation and development of soil structure plays a crucial role in determining soil functions and ecosystem services in Earth's critical zone. Classification of aggregate soil. The classification of aggregate soil is classified by morphology in different groups. According to FAO, the types of soil structure are, the first one is blocky. In blocky, the structure is rounded. It has rounded surface that are cast of the faces of surrounding aggregates, and the subdivision is recommended into angular, with faces intersecting at relatively sharp angles, and subangular blocky faces intersecting at rounded angles. The second one is granular. In granular, they have curved or irregular surfaces that are not cast of the faces of the surrounding aggregates. The third, we can see here that granular structure of soil surface is like this, And the fourth one is the platy. In platy, it is flat with vertical dimension limited, generally oriented on a horizontal plane and usually overlapping. The next is prismatic. In prismatic, the dimensions are limited in the horizontal and extended along the vertical plane. It is extended along the vertical plane and the horizontal dimension is limited. The vertical faces well defined, having flat or slightly rounded surface. This is the prismatic structure of the soil. The next one is columnar. In columnar, the prismatic structures with rounded caps are distinguished as columnar. The next is rock structure. In rock structure, it has fine stratification in unconsolidated sediment. The next is wedge shaped. In wedge shaped, it is elliptical, interlocking lenses that terminates in sharp angles, bounded by silicious sides, not limited to vertic material. The next is crumbs. In crumbs, there are lumps and clots, mainly created by artificial disturbance. Example, tillage. This is the structure of a massive soil. The types of soil structure. There are four types of soil structure mainly. It is determined by the general shape and arrangement of the beds. The four structures are plate-like, prism-like, block-like, and spheroidal. We can see here. This is the plate-like structure of the soil. This is lamina. This is prismatic. This is columnar, and this is angular blocky, this is subangular blocky, this is granular, and this is crumbly. The first one is plate-like structure. In the plate-like structure, the horizontal dimensions are much more developed than the vertical axis. In the vertical axis, it is flattened, it is not much higher. Like it is a compressed or lens-like appearance to the pads. When the units are thick, they are called platy, and when the units are thin, they are called laminar. Like this, there are two types. When the units are thick, they are called platy, and when the units are thin, they are called as laminar. In this, the platy types are often inherited from the parent material. In addition, frost having fluctuating water tables, compaction and thin layering of different textured aluminum or lacustrine material can form platy type of soil structure. The second is prism-like. Going to the prism-like, we can see first that how the plate-like structure is. We can see here that plate-like structure has two types. First is platy and laminar. Like we know that in platy, the horizontal surface is more than the vertical. This is also in the laminar case. And the second one now prism-like. In prism-like structure, the vertical axis is more developed than the others with flattened sides. So we can see here that in prism-like the prismatic structure is high. In prismatic structure, the vertical section is higher in both the cases, prismatic and columnar, and horizontal is not. So it has two different types like columnar. When the top of such pads is rounded, it is rounded in this condition in columnar, and when the top of such pad is rounded, and prismatica when the tops of the prism are still plain, level and clean cut in like this. This is the prism like prismatic. The prism-like structures are commonly found in subsoil horizons and in arid and semi-arid soils. The third one is block-like. In block-like, all three dimensions are same in the size of the peds are and are cube-like with flat or round surface faces. This is the block-like in which all the dimensions are similar, vertical and also horizontal. This is the angular blocky, first type of the blocky like, and the second one is the subangular blocky of the blocky like type of structure of the soil. So these are the two types: angular block when the faces are flat and edges of the cubes are sharp angular, and subangular block when the faces and edges are mainly rounded. The fourth one is spheroidal. It is a spear-like structure. This is the spheroidal spear-like structure. First is the granular and the second is the crumby. So all the axes are developed equally with the same length. Like this, in this also the all the dimensions are same. In this case also all the dimensions are same length, but it is a spear-like structure and it is not a spear-like structure. It is curved and irregular faces. It has curved and irregular faces, but in this condition it is a plain and flat or rounded. Generally, all rounded or spear like beds may be placed in this type of soil structure. The term spheroidal more appropriately referred to those size of aggregates not exceeding half inch in diameter. Granular and crumb structures are characteristics of many surface soil. The classes of the soil. The classes of the soil are classified as each primary structure type of soil is differentiated into five size classes. Like we have seen the type of soil. They are classified by the classes of the soil. They are as follows: that how is the soil? It is very fine or very thin. In case of plate soil structure, we can see that platy soil structure is very fine and very thin. In that case, the horizontal length or um, dimension horizontal dimension is more than the vertical dimension. The second one is the fine or thin. That how is the characteristic of the soil? Is it fine or thin? The third one is the medium, how the medium of the soil is present. The fourth one is the coarse or thick. Is the soil coarse or thick? It can be seen in the platy soil structure that the soil are coarse and thick. Fifth one is very coarse or thick. So like this, the classes of the soil are classified. The grades of the structure are indicates that the degree of disintentness and durability of the individual pairs. First, structureless. That how it is. It is structureless. There are no visible pairs or aggregates present in it. If the appearance is coherent, as in compact clay, the term massive is used, and if non-coherent, as in loose sand, it is called a single grain. The second is weak, that that are formed that are poorly formed and non-durable, and the pairs break into a mixture of a few entire and many broken pairs and much unaggregated material. Third is the moderately well developed, which are fairly durable and distinct. And the fourth one is the strongest, that the bonding in the soil particle is the strongest, and because there is a very well formed pads which are quite durable and distinct. So like this, the structure of the soil are graded. That first one is the structureless, which has not any structure, no visible pad. The second one is the weak, that it is poorly formed and the bonding is not good between the pads and they are broken. The third one is a moderate. In moderate, they are fairly durable and distinct. Fourth one, in strong, they are strong and well formed pairs because there is a strong bond between them. This is the table in which the classification of soil structure done according to the soil survey staff in 1951. There are types of the shape and arrangement of the pairs. That how are there? We know that this is first one is a plate like, the second is prism like, third one is block like, and fourth one is spheroidal. In plate like structure, First is arranged around a horizontal plane, and in prism like there are first one is without rounded caps, with rounded caps. As we now know that how the plate like structure is, it is horizontal axis longer than the vertical axis. In prism like structure, the horizontal axis is shorter than the vertical axis. Both are opposite to each other, and we know that how the block like structure is the plane or the curved surface of the surrounding pads. And the fourth one is spheroidal, which is a spherical in shape polyhedra plane or curved surface not accommodated to faces of surrounding pads. So in this prism like there are two types, prismatic, columnar. We know that how what is prismatic and what is columnar. In block like it is blocky, faces flattened, and subangular blocky. This is mixed rounded. In spheroidal shape, the first one is granular, relatively non-porous bed, and the one is porous bed. So they are classified on their classes like first very fine or very thin. That how is the soil? It size. It is a bed size. Is it very fine or very thin? In this it is classified like these all the types of the soil, like flaty is less than 1 millimeter, prismatic is less than 10 millimeter, columnar is less than 10 millimeter. The second one is a fine or thin, that how is the size, is it fine or thin of the soil pad pets. So this is the platy, like it is a range from 1 to 2 millimeter. This is prismatic, it is range from 10 to 20 millimeter. Like this, all are classified. And the third one is the medium. How is the medium? Like platy in platy, 2 to 5 millimeter. The fourth is coarse or thick. How is the size of a pets? Is it coarse or thick? It is classified like this. The fifth is very coarse or very thick. How is the type of a size of the pad? Very thick or a very coarse? So it is like 10 greater than 10 millimeter in platy, and this is for prismatic greater than 100 millimeter. This is for columnar greater than 100 millimeter. So all these are classified according to the survey done in the 1951. And the C grade is durability of pad, how it is it weak, is it moderate, or is it a strong? So we can see that in weak, poorly formed, they are poorly formed and non-durable. In moderate, they are well formed, moderately durable pads. And in strong, they are well formed, durable, and distinct pad, but they are weakly attached to each other. So this was the survey that was done in 1951, and thank you very much.